All right, this will be our second and final example from 9.2. You'll see that they're all very much the same as you navigate through the different problems here in the 9.2 area. So I chose number 16, and it's dealing with, interestingly enough, tobacco again. And this one's in children's movies. And so they kept track of the time that there was reference to tobacco smoking in a Disney animated movie, and then other animated movies. They kept track of that, and they want us to use the same zero point 0.05 significance level to test the claim that Disney's animated children movies and the other animated children movies have the same mean showing time of tobacco use. And so, no problem. As we go to do part A, our claim is that the mean of Disney is equal to the mean of the others. So one is Disney. So Disney is number one, and other is number two. So what's our null hypothesis? Well, it's the exact same thing. We don't have a choice there. The null hypothesis has to have an equal sign in it. And so what's H1? Well, it can't be the null hypothesis, so therefore it can't even be the claim it wanted to be, but it's got to be the opposite. And so we have a nice two-tailed example again. What are we going to do next? Well, we're going to go get our t value. You know how that's happening. x1 minus x2. So x1, 61.6 seconds. Other movies is x2, 49.3 was their average. Minus 0, always 0 here, because we're always doing the direct comparison, square root, and now I got to get my S1. So S1 would be the standard deviation for Disney movies, 118.8 seconds. That's a pretty big variation in there. And we don't forget to square it, all over 33 plus 69.3 seconds squared all over 17. And we're going to run this. We're going to take our 61.6, subtract away the 49.3, hit equals, divide by the square root, and 118.8 squared, using no parentheses, divided by 33, still using no parentheses, plus 69.3 squared, divided by 17. And we're going to get a t value that is relatively small, 0.4615, so I'll put 0.462. That's exactly what they have as the answer in the back of the book, and so we're doing great. It's a two-tailed test. We know that because it's not equal to. 0.05 is involved, so we got 0.05 and two tails, right? And we're looking at a degree of freedom. Now, this is the first time that we have a choice for degree of freedom. I didn't mention it in the last video because I had forgotten about it, but if you have a choice, you have two ends there. You have 33 and you have 17. The degree of freedom is equal to the smaller of n1 minus 1 and n2 minus 1. And so what's smaller? Well, let's look. My choices are 32, 33 minus 1 or 32, or 16. Well, we're going to use the 16. So we have, remember it was 33 was the first sample size and 17 was the second. So we're choosing the smaller over those. We're going to choose the 16. So when we go to the table, we're going to have 16 degrees of freedom. So we'll go to that 16th row, 0.05 and two tails, and we'll be set. So I'm going to erase that work right there just to clean this up a little bit. And so let me flip back to that. I haven't pre-found that number. So 16 degrees of freedom, 0.05 and two tails is the middle column, and we're looking at the number 2.120. Oops. 2.120. That is our critical values, our positive, negative 2.120. And so that's what they have in the back of the book. They have that coming out from the table. Have a different one if you're able to use a calculator. I'd rather you use the table though. So are we going to reject or fail to reject? Pretty clearly, we're not anywhere close to or we're definitely not beyond 2.120. It doesn't matter how close we are. We're going to fail to reject the null hypothesis. And the wording should be, there is not sufficient evidence to warrant rejection of the claim that, and then let me go look at what 16 said. That Disney and the other animated movies have the same mean. So they could absolutely have the same mean. I cannot say just because my sample shows that Disney has a higher average length of tobacco use being shown, I can't say that Disney movies have that happening overall, because my data is not strong enough. And so I model writing this last bit just to make sure you remember it's an expectation on the exam. I didn't want to skip it because somebody might say, hey, Jensen, in that one video you didn't do that, so I didn't think we had to do it on the exam. You need to do that on the exam because it's been a part of every example, and it's also been a part of every back of the book answer. So your main goal is to match that back of the book answer. Now remember, there's a B that's asking for the confidence interval that's appropriate. Well, this was a two-tailed test, right? It had a negative 2.120 and a positive 2.120. This had a 0.05, this had a 0.05. We're looking at a 90% confidence again. And that's what they'll do. In number 16, they'll talk about how it is, that's not true actually. It is not a 90%. Remember, that 0.05 was split up in the two tails. I never actually showed the split up. It'd be 0.025 in each one, and that's 95% in the middle. And the back of the book would reflect that. So if you made that error, you would know right away that, I called it the wrong thing. Make sure you're writing that you have a 95% confidence interval. And what is it? Well, it's going to be x1 bar minus x2 bar plus or minus some calculated error. What's the x1 bar? Well, we have that. X1 bar was 61.6 seconds. X2 bar was 49.3. So this is great that we'll see one in which there's a fail to reject. And now we got to go get that error. What's that error? Well, it's 2.120 times the square root. And then we got to look at the standard deviations. 118.8 squared over 33 plus 69.3 squared all over 17. And let's go run that. We get 2.120 times 118, times the square root, square root of 118.8 squared divided by 33 times 69.7 squared divided by 17. And then we'll hit equals, and we'll get an error that's equal to, I must have made a mistake. Mine's really big, so I'm going to rework that and see if actually maybe it is that big. I got 741.14. It seems really large, so I'm going to rerun that again. So it's 2.120 times the square root of 118.8 squared divided by 33 plus 69.3 squared divided by 17. That seems more reasonable. The answer that I got with the 700 didn't seem to match the data that was given in terms of the size. I'm getting something way more respectable here, so I apologize for that. And I'm going to go out to one decimal place because that's what they rounded their means as and their standard deviations. So we'll do 56.5. It was 56.49. So now we find out what 61.6 minus 49.3 is. Well, we get a difference of 12.3, and we're going to add and subtract the 56.5. So if I take 12.3 and subtract 56.5, I get a low value of 44.2, but it's negative, and that's mu1 minus mu2, and I get a high value of 68.8. Now these are in seconds, and so I would double check that answer by going to the back of the book, and we're looking really good. We're matching the ones that come out for the table. So remember, they have the two values in there. One if you were using a calculator function, and the other if you're using a table. You should match the table. That's what we have. Otherwise, I'd have to prescribe a particular calculator, and I didn't want to have to do that. So notice that mu1 minus mu2 really could be 0, because 0's in that interval, which means you can't reject the fact that they're the same. So the Disney movie might have the exact same mean content in terms of tobacco content and time as the non-Disney animated movies. But we're also learning that the Disney movie could have less or even more because we span from negatives to positives. So we really don't know anything when we fail to reject. We just have to take more and more data if we really cared about making a conclusion. But right now we really can't make a conclusion. Our data is not sufficient, right? Our mu1 minus mu2 includes the 0. Both of those are the same. We fail at our attempt to say something strong because our data is not sufficient. It's not strong enough. Alright, so those are a couple examples from 9.2. Hopefully that and what the book has will be sufficient for you. But if not, hop on to Zoom and we'll be happy to help you out.